go. Okay, I think it's working. Yes. All right. Just as a reminder, 1, 3, the back side of this section has 1, 4 on it, but we are only doing notes for 1, 3, which means that you have to hold on to this note sheet for tomorrow when we do 1, 4, right? I told the 5th period class that, and guess what?
They lost it.
No. I have Jake Boniface's paper right here because he left it on the floor. And I'm not telling him that it is in here so he can freak out tomorrow. So don't tell him, everybody on the video, that I have Jake Boniface's paper because he can sweat and not be able to find it.
He probably won't even freak out.
He probably won't. He'll probably I told him I'm not going to give you an extra copy. Okay, so slope. Slope, a lot of times the variable that we use for slope is m. Okay, variable that we use for slope is m. We will eventually get to the point where we're doing things in slope-intercept form, which is y equals mx plus b. And that m is that slope that goes in mx plus b, okay? We'll get to that form here shortly, like tomorrow, okay? So rate of change is a ratio that compares one quantity changing over another quantity. So a lot of times you'll see this and you'll see like miles per hour. So the rate at which you are traveling in miles divided by the number of, or the amount of time it takes in hours, miles per hour is a rate, okay? And you always do the change in y over the change in x when you have like points here because it is the rise over the run. You guys have heard that before for slope, right? Rise over run, okay? A lot of people when they, or my Algebra 2 kids, when you guys start doing stuff with slope first, they get these two mixed up. X and y, they flip those around. Don't flip them around. Don't write that on your paper. Don't flip those around, okay? Why not? Why do they put the x on the top and the y on the bottom? A lot of times.
Because in like that thing, the x goes first.
In the ordered pair, the x goes first. So it would make sense to put the x on the top, but it doesn't. X doesn't go on the top. Y goes on top because it's rise. The rise values are the y values up and down. The run values are the x values left and right. Okay. Our first question they have here, we are looking at the constant rate of change of a temperature solution after it has been removed from a heat source. So there's heating up this little beaker here, and then they're removing it from the heat source, and then it's gonna go down and down and down and down and down in temperature. Okay. So the amount of time, so right after I take it off of the heat source, it is 143.6. 2 minutes later, it's 139.4. 5 minutes later, it's 133.1. Or 5 minutes after the original time. 8 minutes after it's originally taken off, it's 126.8, etc., going all the way down, okay? So let's look at the rate of change. So the first time we record is at 0 minutes. The second time we record, we're at 2 minutes. 2 minutes have elapsed from 0 to 2 minutes, right? And how many degrees have I gone down from one to the other? How many degrees have I decreased?
4.
I think it's something like
It's
4.2 degrees, I believe. Yeah. Okay. From 2 to 5, there's 3 more minutes that have elapsed. How many degrees have I decreased from there? I've decreased 6.3 degrees. Okay. From 5 to 8 minutes, that's another 3 minutes that have passed. And how many degrees have I gone down there?
7.7.
I think that's 6.3 degrees again.
Oh,
yeah, 6.3 degrees again. Okay, and then from 8 to 12, that's 4 minutes, and I've gone down like something like 8.4 degrees. Okay, so I'm looking at those guys. Now, we always do the y coordinate over the x coordinate. So the first time, he's gone down 4.2 degrees in the amount of 2 minutes. Okay. The second time I measure, he's gone down 6.3 degrees in the amount of 3 minutes. Then he went down another 6.3 degrees in the amount of 3 minutes. And the last time I record, he's gone down 8.4 degrees in 4 minutes. Okay? Now, if I look at each one of those and divide those out, what's negative 4.2 divided by 2?
2.1.
Negative 2.1. What about 6.3 divided by 3?
3.1.
2.1?
2.1.
2.1, okay. Same thing, negative 2.1 and 8.4 divided by 4?
2.1.
Negative 2.1. So my rate of change is negative 2.1. What does that mean, like according to the story problem? What's happening? It's the slope. That is the slope. Yep, slope is that, okay. But this means that it's going down 2.1 degrees per
Second. Minute.
minute per minute, okay? So if it's doing 4.2 degrees every 2 minutes, then that means it's going 2.1 degrees every 1 minute. That's my slope. That's my rate of change. That's how much it's changing, okay? So average rate of change, we have two things going on here. This line right here is telling me digital music sales, and they are in millions of dollars. So don't worry about the millions of dollars right yet, okay? They have 2 points that they're wanting us to pick on. Then they're going to have us compare that to the value of e-books. What are e-books?
Computer.
Like Kindle books or whatever. And they have 2 points that they want us to pick on there. So they're saying, look at the sales from 2004 to 2009. So we're going to do digital music first. Digital music. Okay? And then we'll do ebooks over there. So digital music, I'll just do ebooks right now. Ebooks. Digital music. In 2004, what was the amount for digital music?
200.
200. You can see that? Okay? And in 2000, what was it for ebooks? 2004, excuse me. What was it for ebooks? 9.6. So these two values here, 9.6. Okay, let's go up to 2009. 2009 is 3100, you betcha. And ebooks in 2009? 165.8. Okay, now, when you're given two coordinate points like this, do you know how to find the slope? It's down here, the formula.
Oh.
Okay, have you heard that before? Y2 minus Y1 over X2 minus X1. Okay, this is the change in Y's over the change in X's. Right, change is the symbol that we denote for change is a triangle. So it's the change of Y over the change in X. So it's how is the Y coordinates changing over how are the X coordinates changing. So let's do digital music over here. So I say Y2 minus Y1 over X2 minus X1. That's great, but if you don't know what X1 and Y1 and X2 and Y2 are, you're just in big trouble. What's X1 and Y1?
209 points.
X, Y, X, Y, right?
Yeah.
Okay, which one's the first X?
2000.
2004. The first Y is 200. The second X is 2009. The second Y is 3100, right? The first set, the second set, X, Y, X, Y. Yep. Okay, so we want to do Y2 minus Y1. Y2 is
1300.
3100 minus 200 over 2009 minus 2004. Okay, 3100 minus 200 is
2900.
2900. Good math. 2009 minus 2004 is
5.
5 years. So what they're saying is this amount has gone up $2,900, and it's really $2,900 million in the amount of 5 years. So how much has it gone up in 1 year on average? 2,900 divided by 5 is 580, I think. I'm pretty sure. Okay, so it has gone up $580 million per year on average. Okay, on average it goes up $580 million per year. Now, Chase said 5th period, he said, but it's not going up the same amount every year, right? It starts going up really quickly and then it kind of levels off a little bit in the end right here. Okay, but we're doing on average. We're doing from start to finish on average, it's $580 million per year. Okay, now we're going to compare that to ebooks. Is that one going to go up more or less than digital music? Way less. Ebooks is like almost a flat line, right? So we're going to do Y2 minus Y1, X2 minus X1. What's your second Y coordinate?
2009.
165.
165.8. Yep, that's the X. So you want to make sure it's the Y. 165.8 minus 9.6. And then 2009 minus 2004. Okay? 165.8 minus 9.6 is 156.2. Check me.
We're smart. How about you do that?
Yes.
Yeah?
Yes.
And then 156.2 divided by 5 is 31.24. Is that right? We'll go with that. 31.24 million is the average slope, is the average amount that it's going up per year is 31.24 million is the average amount it's going up. Okay, so if we compare those two, we can see that digital music is way, way, way more popular and gaining speed way faster than what ebooks are. Why? Because nobody likes to read, right? Do you believe that that's probably the case? Digital music is way more popular than ebooks. I believe that's probably true. Okay. All right, example 3 is doing the same thing again. What?
Ebooks read to you, though.
Some of them do, yeah. So I don't know.
It sing to you.
So it sings to you and then one reads to you. I don't know. People still probably prefer music over reading though.
Yeah.
Okay.
What if you get an ebook and it's still digital music?
Oh, you mean, is that still considered digital music? I don't know.
Yeah.
I don't know. Probably not. They still count it as an ebook, I'm guessing. I don't know. That's a good point though. Okay, so example 3, we're using that same concept except they've taken away the story problem to it. They're just saying find the slope of those 2 points. Okay, so we want to do y2 minus y1, x2 minus x1. What's your second y?
2.
No.
5.
5. Second y coordinate is 5.
3.
First y coordinate is 3. 5 minus 3. And then
2 minus
2 minus negative 4, which means we do 2 plus 4. Awesome. Okay, 5 minus 3 is 2. 2 plus 4 is 6. Okay, so
1/3.
1/3. Now, do not write your slopes as a decimal. Okay, you reduce it in lowest terms, but don't ever write it as a decimal because when we start to put him into an equation like up here, we're going to want that slope to be as a fraction, even if it's an ugly fraction. Okay, so go ahead and leave him as a fraction, not a decimal. Good? Okay, now, they're giving us a graph on this next one, and they want us to find the slope. So we're going to pick points where they cross really nicely. Where does it cross nice on the graph?
X and Y.
Yeah, the x and y intercept, those cross really nicely. So this guy would be at negative 2 comma 0. That doesn't look like a 2. Negative 2 comma 0, and this guy is at
-3.
0, negative 3. Okay, now, we're more than welcome to, after we identify those 2 points, to plug it into the equation, or we can use the graph to our advantage, and we can just simply do rise over run. Okay, rise over run. So we start and we go left to right. Okay, so which one is the left point? Which one is more left than the other one? Which one is like the leftmost point? So we're starting with negative 2. So this is going to be where I'm starting from. Okay, and to get from negative 2, 0 to 0, negative 3, how much am I rising? This is kind of a weird question to ask. How much am I rising from negative 2, 0 to 0, negative 3?
You're going.
I'm technically rising a negative value, right? I'm rising a negative 3. Does that make sense? Are you okay? What?
1.5.
3?
1.5. Limited? She does this all
No.
the time.
She's right. What's wrong with 3? Oh, the way she said it. 3. Oh, boy. Oh, boy. All right, so I'm rising a negative 3. I'm going down 3. That's the distance from here to here. And how much am I running to get from that point over?
2.
2. I am running 2, so my slope is negative 3 halves. Yeah? From one point to the other, I'm going down 3 over 2. Done. Okay? Now, I had Jake Hodson this morning said, oh, I did it differently. He said, I got 3 over negative 2.
Does that work?
Does that work?
I don't know.
Is negative 3 over 2 different than 3 over negative 2?
No.
No, they're the same thing. You can put the negative in the top or the negative in the bottom, or you can do one other thing, which is put the negative out front, right? All of those things mean the same thing, and it doesn't matter, right?
Yeah.
So negative on top, negative on bottom, as long as you only have one negative, right? Okay, so all of those things mean the same thing. So that is all I have for you. That's it. Really nice, easy day today. Oh, homework page, if you didn't write this down yesterday, for the people who are on the video, page 24. It is 10 through 34, the evens. Okay? And we will turn in homework for 1, 2, and 1, 3 tomorrow.